All right, what are we doing today? Live algebra calculus. The more of the same stuff. Okay, so let's go to that worksheet. You can look at it on Edmodo if you want. Same worksheet. Now we did 1 and 3. You did 2 or 4 for homework. And let's take a look at why did Dropbox add this option I don't want?
You just have to do 2 on Dropbox.
2 or 4, yeah, one of them. All right, so that was 4. All right, so what was 5? Oh, that's a good one. Good, let's do this. No, we didn't. All right, so it's the same idea. Can you do this though? Let's see. Oh, this is tricky. This is gonna be tricky. Hang on. Oh, we got Ryan. We got Morgan. Okay. All right. So let y equal a MaLlaurin series, an infinite MaLlaurin power series, approximating the solution curve for the following differential equation with initial condition. All right. So y prime is 1 over 1 plus x, and y of 0 is 1. Use the given series to solve this differential equation and classify it as a finite or infinite series. Graph this thing. What kind of solution is it? Solve it by variable separable. Can you do it by variable separable also? In other words, did you get a series for a function that you know? Well, how would you do this? How did we do it last time? Think what you did with the homework. You start with y equals a plus, then you go to y prime equals b plus 2c, right? But what do you write for this thing? 1 over 1 plus x. You want to make your y prime series equal to a series for 1 over 1 plus x.
1 plus x to the negative 1.
1 plus x to the negative 1. Well, yeah, but I need a series, though. That's a function. I need a series that represents that function.
Right.
Does this look familiar at all? Do you not know a series expansion for this?
Oh, yeah.
Isn't it? Dare I say it?
Yeah,
Give it away?
yeah.
Geometry. A over 1 minus r, right? So the first term is a, which is 1, and the common ratio is r, which is not x, negative x, because it's 1 minus r, so x, negative x has to be, okay. So let's do it. Here we go. So this is number 6. Sorry, number 5. 6 is homework. So y is a plus bx plus cx squared plus dx cubed. We do a whole bunch of terms here in case we need to get some kind of a pattern, like for a general term or something. Okay. Alrighty. And so y prime, you know it. It's b plus 2cx plus 3 dx squared. Okay, plus 4ex cubed plus. So what's weird here is all we're doing is power rule for derivatives. We're not using antiderivatives really to solve a differential equation. That's really weird. Plus 6gx to the 5th plus 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 forever. All right, so the series of 1 over 1 plus x you said is what? You said it. First term? 1. Next term? If the common ratio was, what'd you say? Negative x. What do you do with the common ratio to get the next term? Multiply by it. So 1 times negative x. Negative x times negative x. Times negative x times negative x times negative x, right? Lako, did you kill somebody else? How many people did he kill? You're only supposed to kill Savannah, right? Where'd Savannah go? She's really dead. Oh, all right. I was kind of like, wait, I'm looking over here. All right, did I miss a question? Someone said, wait.
I think for a geometric series, it's the first term over.
A geometric series, let's see, a geometric series, how am I going to write this? A over 1 minus r is sigma ar to the n as n goes from 0 to infinity. If and only if r in absolute value is less than 1. Okay, right? Okay. So there you go. There you go. So what are you going to do? Well, they gave me an initial condition, didn't they? What was it? Y of 0 is 1. Why don't we start there? If y of 0 is 1, plug in 0 for all the x's in the first line. A has to be 1. Okay. Give me a pen. All right. So now how are you going to get b? Well, b is clearly, do you see it? We're matching these two lines here, term for term for term, degree by degree by degree. So b has to be 1. All right, now what? How do you get c then? 2c's got to be -1. If 2c is -1, c is -1/2. So let's write that down. Alrighty. And then 3d is, so 3d is 1, d is a third. Is this a strictly alternating series after the 1, 1? Is it going to keep on changing sign? Let's see. 4e is -1, so e is -1/4. Okay. 5f is +1, so f is a fifth. And so g? G is going to be what? -1/6. All right, so if you write it out, y is 1 plus 1x plus -1/2 x squared, so -x squared over 2, plus x cubed over 3, minus x to the 4th over 4, plus x to the 5 over 5, is that what we're getting? Minus x to the 6 over 6. And you can easily get a general term here, an interval convergence, and a radius of convergence, and the center of convergence, and do the ratio test graphs of convergence and fun stuff. But doesn't that look familiar at all? Do you remember, a lot of times when we did the expansions, like for sine and cosine, there were factorials on the bottom, right? But do you remember when we didn't get factorials on the bottom? That happened. When we're dealing with what function? That comes up. Don't remember. Where were you during the AP exam? You were at the district office, but okay. Were you there in spirit, or were you really there? All right. No, you don't remember? We did. Which one? Not trig. Trig had factorials. ln, and some a weird trig, inverse trig functions. Inverse trig functions do this, and ln, right? Arctan does this. ln does this. So is this an arctan or an ln? Well, let's find out. Go to the rest of the question. Is this an infinite or a finite series? Infinite. Is it logarithmic, sinusoidal? See, that's what we don't know yet, right? So you could graph it. What do you mean graph it? Graph y equals 1. What does that look like? Horizontal line. Y equals 1 plus x. What does that look like? Slope of 1, y intercept of 1. Y equals 1 plus x minus x squared over 3. Parabolic, right? So as we add on more and more terms, we're going to get more and more of the shape of the curve, right? And so what is it? Well, let's find out. Let's do this last part. Variable separable. Can we solve this by variable separable? And can confirm our result. So let's see. What do we got? We've got that dy dx is 1 over 1 plus x, and y of 0 is 1. All right, how do you separate this thing? Real hard. All you got to do is multiply by dx, right? dy equals dx over 1 plus x. You've separated the variables in such a way that it's integrable. The dx is in the numerator, the dy is in the numerator, the x's are with the dx's, the y's are with dy's, there weren't any y's. So integralize, and you say y equals, it is ln, isn't it? 1 over u du. It's not even a u sub. Well, I mean, it's a u sub, but you don't have to divide both sides by 2. Right, like we do. What's du? Du is 2x. So what do you replace dx with? Du over 2, right? That stuff. I even have to do this. This is already 1 over u du. So ln absolute u plus I'm just a constant. Nobody loves. All right. How do you get c? Plug in 0. So you plug in 0 for x. You get 1 plus 0 is usually. There's always somebody to cry. 1 plus 0 is usually, according to Connor, it's 0. What do you say? 1. But ln of 1, you were close, is 0. So c plus 0 is c, is y, is 1. Oh, okay. So it's, there's your general solution, but your particular solution is this. And so it is logarithmic. There you go. Okay? This happens a lot with arctan too. I don't know if arcsine, arccosine, but arctan, definitely. Alrighty, so that was number 5. Easy peasy. Are we okay? If you need to do homework tonight, let's see. Let's see number 6. Yes, you may. All right, let's see, what's number 6? Is that good for homework? Come on. Let's see what 6 looks like. It's almost, it's the exact same thing. Not quite, not exactly the same thing, but damn close. So if you didn't do the homework yet, you could do that. All right, who didn't do the homework yet? You need a homework check this week. No makeup week, so do this tonight. Give it, just hand it in tomorrow. You had to do 2 or 4 last time. I'm saying probably 6 or 8 tonight. If you didn't do it yet. If you did a homework check this week, you're done. No. All right, 1 homework this week, that's all. Let's make it easy. All right, look at now. What's special about this one?
There's another letter there.
Let's go straight to part D. Solve this first order differential equation using the method of separation of variables if possible. If not possible, explain why. Well, is it variable separable? No. Right? If this was x times y, you could divide, multiply. But x plus y? Ugh. So this is a nice technique to deal with problems that you can't do the normal way. You can't do this by variable separable. All right, so let's do the same technique. Use a MaLlaurin series for y. Set y prime equal to x plus y. And figure out the constants of your MaLlaurin. All right, so 7. What is it now? So y prime equals x plus y. Was there an initial condition?
Yeah,
y of 0 is 1. That's arbitrary. It could be anything really. So y of 0 is 1, as long as it's in the domain, function's defined, and so forth. All right, so y again is, let's assume it's MaLlaurin. This is a MaLlaurin series where a is usually f of 0, b is usually f prime of 0, c is usually f double prime of 0, and so forth. But we're going backwards. We don't know f, so we can't get f prime of 0, whatever. So let's work this backwards. And get a lot of terms here in case you want to get a pattern going, right? All right, so y prime is again b plus 2cx plus 3d x squared plus 4ex cubed plus 5, am I up to f x to the 4th plus 6g x to the 5th plus forever. All right, so what's a? A's got to be 1 again, right? Right, plugging in 0 for all these x's. Y is 1, so a is 1. All right. What's b? Is b also 1? A is b and a, they're equal. All right, so that's 1. All right, now what about c? Now wait a minute, that's not right. You messed up already. That's wrong. You messed up already. We're not setting y prime equal to 1. We're setting y prime equal to x plus y. This isn't x plus y. What's x plus y?
A plus x.
If you add x to this thing, right? If you add x to this thing, you're only adding it to this term, like terms, right? So x plus y, all right, let's write it down here. X plus y is going to be a plus what? If you add bx plus x, no. Bx plus x, how do you add like terms? You can. Do you not realize that adding like terms is just factoring?
Really?
Factor out
Oh, b
x, so b plus 1x, right? If it's 2x plus 3x, factor out the x. What do you got? 5x. When you're combining like terms, you're factoring. Yes? Okay. All right, so now the rest is the same. Right, the rest of the series is the same. Just write it down. This is the b term. All right, here's the c term. Here's the d term. And I only need this many terms because that's all I'm matching up. All right. So we've got that a is 0, a is 1 by plugging in the initial condition. And b is a, so that's okay. But b is a, so that's okay. But b is, what am I doing? Let's go here. A is 1. B is 1. But 2c, here we go. 2c is b plus 1, but b is 1. So c is 1. Oh, okay. It's okay so far? All right, so we set a equal to b. We set, well, b equal to a, 2c equal to b plus 1. How about 3d equal to c, right? So 3D is equal to C, but C is 1. But C is 1, D is 1/3. All right, so now it's acting more normally. All right, so we set 3D equal to C, now what? 4E is equal to D. All right, so if 4E is equal to D, but D is 1/3, E is what? A 12th. Okay. Then we're going to set what equal to what? Next step. 5F equal to E, but E is a 12th. So 5F is E. Well, E is a 12th. So you get a 60th? Okay. So F is a 60th. Let's write that down. And can we get G? 6G is F, but F is 1/60th, so G is 1/360. And there you go. Wow, that's a weird series.
Yeah.
Let's make room down here. All right, so what's the answer? So my answer is y equals a plus bx plus cx squared plus dx cubed plus ex to the 4th. These are all positive, right? There's no negatives going on? Okay, plus x to the f times 1/60th and so forth. Is there a pattern here? You see a pattern? Could we get a general term? Could we get an interval of convergence? Could we get a center of convergence? Could we get a radius of convergence? Absolute ratio test of convergence, all that fun stuff?
It's being multiplied by 1 plus
Okay.
numbers multiplied by
Times the factorial.
yeah.
So, all right, what do you think? All right, what should I write? Sigma what?
Sigma 2 over factorial n.
2 over factorial of n?
Yeah, plus. Oh no, of n plus 1.
N plus 1 factorial?
Oh no, n minus 1, sorry. Right.
Well, it depends where your n starts. N starting where?
That would be for 0.
If n starts at 0, n minus 1 is -1. You really want to go there?
That's right.
Negative 1 factorial? I don't think you want to go there.
So we do n and n starts at 1.
N starts at 1? Goes to infinity?
Yeah.
So if you plug in 1, you got 2. What that coefficient is who?
Test.
Starting here, starting here?
No, we should do n starts at 0 and just n.
Just n.
N fact, yeah.
Okay, but still. Where's the 2 coming from in here?
Well, it's 2.
If you plug in 0, you got 2. If you plug in 1, you still got 2. Why the 2?
Oh, it shouldn't be 1.
I'm not seeing the pattern here. Are these? Let's see, 3, 4 times 3, 5 times 12.
It's multiplying by the exponent. The previous denominator is being multiplied by the next exponent.
Right, right? Okay, well, how do you write that in the sigma notation?
Just do n minus 1 times n on the bottom.
All right, let me, I think I need room for this thing. All right, sigma what?
X to the n
X to the n.
times over n minus 1 times n.
N minus 1 times n?
Yeah.
N starts at?
Has to be 1.
Well, 1's going to be a problem.
Yeah.
All right, say we start at 2. Does this work from 2 on? If it works from 2 on, just add on 1 plus x, big deal, right? If you can get a series for infinitely many terms, you're good. So let's see, if you plug in 2 to get this.
Yeah.
No,
No.
you don't. Because 2 minus 1 is 1 times 2 is a half, right?
Yeah.
If you plug in 3, you get the exponent, right? But the 3, you get 2 times 3 is 6. You get 2 times too many. Is that the 2 you were talking about? You get 2 times too many? No? Do you need the 2? You said that you needed a 2 for some reason.
I was at a 2 because.
It seems like I'm off by 2, right?
Yeah.
Yeah.
It's the factorial.
So if I plug in 2, I get x squared. If I plug in 3, I get x cubed over 3. If I plug in 4, I get 3 times 4 is 12, but the 2 now messes it up. Yeah. Yeah, I can't get a general term out of this.
So we get Mr. Mac.
Huh?
Mr. Mac.
Mr. Mac. Okay. If you can't get a general term, then you can't get an interval convergence. What are you going to do? All right. Wait. Now, just for fun, what does DE solve say about this? What if we plug this into DE solve? You think DE solve can handle this?
Let's see, I'm sorry. Can I believe kitchens belongs to
Who do you need?
Blake?
Blake? They took him already. Someone came for him already.
No, it's stuff.
Oh, his stuff. Okay. Where did he leave his stuff? Okay. Are you guys getting in trouble for this? What did he do? Did he really kill you? I thought he was bragging so much about it when he walks in. And I'm like, you're really not supposed to kill the victim, right? For real. Just I took the spoon and. All right. So, all right, let's go to the calculator. Let's see. Where's my? All right. Let's see what DE solve says about this. Come on, DE solve. All right, DE solve. Go. Come on. Wake up. Wake up, Castiel. Let's do a DE solve. All right, so new document, calculator, menu. Menu. All right, what do I want? Like yesterday. We did DE solve yesterday, right? Where was it? Where's DE solve? Where's in a calculus? Then, now it's way at the bottom, isn't it? All right. By the way, what about this series thing? Have you used this?
No.
I think that's the Taylor command. You can do a Taylor expansion, even in MaLlaurin. But let's do this one. I'm just curious. What the heck can we do with this? Now, remember how this works? You write the differential equation, right, which was what? It was y prime. Prime was over here. Equals, what was it, x plus y, right?
Yeah.
Oh, yeah, that was good. Okay, comma. All right, and then was it the independent first, then the dependent, I think? So x, comma, y. So you could use, y and t, or, p and t, whatever you want. Comma, y. And that's it, right? That was it? Let's see if it gives me something. Huh. So it's e to the x minus 1? Really? Is that what it is?
Of course it is.
Of course it is.
Wait, what? Wait, what's the series for e to the x? You know this. E to the x.
1 plus x.
Dang it. E to the x is 1 plus x plus x squared over 2 factorial plus
X cubed over 3 factorial.
x cubed over 3 factorial plus x to the 4th over 4 factorial plus, right? But it said minus x minus 1. So minus that?
So in the constants.
It starts off
Plus a constant, yeah.
Yeah.
But it said plus a constant, right?
Yeah.
Where did it go? Calculator, where are you? Where'd it go?
So the
Times a constant. No, times a constant.
yeah.
So it's e to the x times stuff
minus x.
minus x minus 1. Wow, that's weird.
Why is it minus?
So this goes away.
Well, no,
That's-
not
that's-
yet. You gotta multiply first.
Oh, we multiply everything through by something. Well, okay, so what's it off by? It's off by 2, right?
Yeah.
Multiply the 2 again. You get instinct. I like it. Multiply by 2. That 2 goes away. Multiply this by 2. Good. Multiply this by 2. Good. What's 4 factorial? 24 times 2? Yeah. Right? What's 5 factorial? And then the 2 on top? Yeah. Okay, I like that. All right. So the constant is 2. So it's 2, all right, so it's 2e, dang it. It's 2e to the x is, multiply this by 2. 2 plus 2x plus x squared plus x cubed
Oh, because it's minus
over 3 minus the extra. There, do you see it?
Right, yeah.
Plus x to the 4th over 12 plus x to the 5th over. That's hard to do by hand. I don't know how the heck you would have done that like during an AP exam or something.
What was this actual?
No, but I mean, it's possible, I guess. And then minus the x and minus the 1 gets, there you go. Yeah, that's it. So it's 2 to the x. So we figured out this constant, the c1. It's 2. 2 to the x minus 1. That's what it is. Alrighty. By the way, just for fun, how does this work? Menu, calculus, what am I looking for? Series. How does series work? Do you want a Taylor polynomial? Do you want a generalized series? Do you want a dominant term? I think a Taylor polynomial will do. Thank you very much. All right. Now, how did we get the syntax last time? Where was the syntax? Syntax wasn't listed there. Where was it listed last time?
Library. The book.
In the library thing, right? All right, let's do it that way then. All right, so
Right next to you.
get rid of this. I just want to get rid of this. Oh, wait, does it take all day to do it? All right, so library. And then go down to Taylor. No. Oh, series. Enter. And Taylor. And I missed it, dang it. I hit enter too fast. So library, Taylor, there it is. So expression, variable, order, value. And the value's in square brackets, so it's optional. All right, so the expression is a function you're trying to get the Taylor series for. The variable is the independent variable you're talking about. And the order is the degree of the Taylor polynomial you want. So let's see if we can figure that out. So if I want, say, a series for e to the x, let's see if we can recognize this. E to the x, no. You know, I know how to do this. Okay, e to the x, no. Delete it. E to the x, jeez. All right, get out of the exponent, comma, x, comma, the order that you want. So like say, I don't know, 4th degree polynomial. Let's see, is that what that means? Is that what we would expect for e to the x? 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial. Right? Okay. Now let's put in the answer that we got. Wasn't it 2 to the x minus x minus 1? Let's see if it matches our series. And, all right, so I'm going to just take this, enter. And let's make it 2 times e to the x. Go. Minus x minus 1. Does it match our series after all? How about we throw in 6 terms? Didn't we have 6 terms? And there it is. That's exactly what we had. Yep. Amazing. So the Taylor, notice it defaults not to Taylor but to MaLlaurin. So could it be that, what if I didn't want MaLlaurin? Expand near 0. What if I wanted to expand near 1? Is that what that last parameter is? Let's see if we get a nice Taylor series expansion near 1. Comma, so comma 1. So if this is correct, it should not be powers of x, it should be powers of x minus 1, like x minus 1 squared, x minus 1 cubed, right, when we did Taylor? Is that what that means? I'm just curious. That's what that means. Look, there it is. Yep, expansion near 1. So you can get Taylor. If you don't want MaLlaurin, leave this blank, or put 0. If you want Taylor, put in where you're expanding, near 1, near 10, near 100, whatever it is. Okay, so that's nice. I like it. All right. So that was 7. So you could do, we did 5 and 7, so you could do 6 or 8 for homework. If you need a homework check for this week, if you did a homework check for this week already, you don't have to do it. And 8 is very similar. Take a look at 9. Now look, we have a second order differential equation. How do you solve that? Have you ever solved second order differential equations by variable separable? No. So this is a more powerful technique, isn't it? I think I can do this. So do the same steps. Write y, write y prime, write y double prime, set it equal to -1. And then you got 2 initial conditions, right? Because it's like 2 antiderivatives, 2 constants of integration would show up if you did it by variable separately, right? The only time we've solved second order differential equations is in the Galilean model, right? Where the acceleration due to gravity is negative g. So dv dt is negative g, solve for v. But then v in turn is dy dt, so solve for y. So you can break it down into steps. But this doesn't have that structure. I can't break it down that way. All right, see if we can do this. Okay, so y double prime is negative y. And what was it? Y of 0 is 0 and y prime of 0 is 1? Y of 0 is 0 and y prime of 0 is 1. So the tangent line at x equals 0 has a 45-degree line slope, and that occurs at the origin. Okay. Do you know any curve that looks like that? It goes through 0, 0, and there's a slope of 1 there. If you draw the tangent line at 0, 0, has a slope of 1. Does this sound familiar at all? Do you know any function whose second derivative is the opposite of itself? You should already know the answer. No? No? You don't see it? No? Okay, let's do it the hard way.
Oh, it's sine function?
It's sine. It's got to be sinusoidal. You didn't speak up. Speak
Oh my
it.
God.
Lucy,
You're
explain.
like
Lucy.
5
Okay.
feet away.
That's the problem, I guess.
All right.
It's to be that way. All right, let's see if your guess is correct. Y prime is, as it's always been, but we need y double prime. All right, so now what do you write? 2c plus 6dx plus 12ex squared plus, where am I? Yeah, 20. That's a 2. Dang it. 20 f x to the third plus 30 g x to the fourth plus. Okay. So, all right. If you plug in 0 for x in the first line and you set it equal to 0, what's a? 0. Right? Zero's out all the x's and it equals 0, so a is 0. All right. Now, y double prime is equal to negative y. So 2c's got to be negative 0. Can you solve for b right now? B?
Gives you y prime of 0 is equal to 1.
Well, what I'm, okay, true, by the way. You can do that too, yeah. They just took them in chains. Okay. All right. Sorry. I couldn't help it. Yeah, sure. Plug in 0 for these x's in the second line, and b's got to be y prime, which is 1 also. Okay, so that's 1. But do you see that what we're doing is we're setting 2c equal to negative 0, because y double prime is negative y, and negative 0 is just 0, right? So if 2c is 0, c is 0. All right. 6d is negative 1. So what's d? Negative is 6. Okay. 12fe is 0. 20f is negative is 6, so negative 1/20th. Is this sign? I think so. Right, it's going to work out as sign. X minus x cubed over 3 factorial plus x to the 5th over 5 factorial, right? Yeah, so it's not y, we just add x to this 1.
Oh, why didn't we add it?
Because they're not like that. How do you add x? You add it to like that. All right, that's it, YouTube. Have a nice day. Life After Calculus continues on Monday.